Welcome to another stream where I'll be learning Python with AI. Last time we did the text stats script and we went through it all and figured out what all the gibberish meant, and we also did the PyTest script for it. And this time we'll be moving on to exercise 8 to build a tiny BPE tokenizer from text, vocab merges and encode/decode using your text stats frequencies as the seed. So I suppose we'll be building from the text stats script somehow, or maybe using this as a module of sorts, if I had to guess. And yeah, I think we have exhausted this exercise, so let's just ask for the next exercise straight away. Let's move on to exercise to the next exercise. I think it was exercise 8, but I don't want to type the wrong number and I'm not entirely sure. Yeah, it seems to have grabbed onto the correct exercise at least. And I changed up the music as well to some lo-fi this time instead of the retro wave I used before. I like both, but I want some variation. Okay, so awesome, time for exercise 8. Build a tiny BPE tokenizer from scratch. What you'll build: a minimal sentence piece style BPE that trains merges from text. Trains merges. I'm not entirely sure what that means. Encodes text into token IDs, decodes IDs back to text. Is reversible for what it sees at train time. Interesting. Design choices simple and robust. Work at the character level with special space marker. Each word becomes some characters. And BP then, oh yeah, for cafe, the same example that it used last time. So it will split all the words into, and the white spaces into this then, into individual characters. BP then merges frequent adjacent symbols into bigger tokens. Oh, so these are smaller tokens that then get merged into bigger tokens. Is my guess at least. Preprocessing flags normalize, NFKC, and lower case fold, same as your text stats. Save a tiny JSON model, vocabulary, of course. Plus merges plus settings, greedy encode, apply merges in the order learned. Okay, simple and deterministic. Create tiny bp.py in the root. So in here we create tiny bpe.py. It's a bit annoying that the PyLens, I think is complaining at these problems here. Oh no, Ruff is complaining. Can I just disable for Wait, what did I do? Oh. So this simply stopped her from complaining about it. Disable. It might be prudent to actually remove these, but I don't want to break anything. Not when I'm like done with the exercise. That would just feel stupid. Okay. So in the TinyBP script, let's see, do we have explanations for each? Oh, this is a long piece. No, we don't have explanations. Then we'll have to wing it as we go. Wing it as we go? We'll have to wing it, or we'll have to... How do you say this? It's either we'll have to wing it or we'll have to figure it out as we go. Let's say that. It's from future, import annotations. And then import argparse, import JSON, import sys, import Unicode data, and then import from collections import counter, from path lib import path, and from typing import iterable list and tuple. Tuple? Built-in immutable sequence. If no argument is given, the constructor returns an empty tuple. But what is a tuple? It's a class, but tuple accepts variable numbers of parameters. So it might be useful with the arguments or something, maybe. Space equals underscore. I think this is a underscore, but it's a bit hard to say with the font difference. If I do this, no, this is another type of sign. The question is if I should copy this or just use an underscore. That's actually pretty hard. I mean, I have no idea how to type this character, but it's obviously more specific, so maybe it's better to use for the training data or for the token rather than a simple underscore. I'm gonna do this. Visible space marker, sentence piece convention. Wait, sentence piece convention. I don't know what that means. Let's just change this to the exact character chat GPT used if problematic. So if we have some errors later, then I might remember to change this back to this. Maybe. Okay, and then the text. It returns a string. Wait. It Oh, I was just hung up on all the errors, but that's because I'm not used to seeing the errors as I'm typing. So if do norm text equals Unicode data dot normalize FKC FKC and text. Wait, there might be still a. That's just because we haven't returned anything yet. But then we do if do lower text equals text dot caseful, and then text equals Unicode data dot normalize NFC. And NFC, I don't know why I keep forgetting the N. Text, and then we return text. Okay. And then words, 2 symbols. Sequence, I suppose. Text string to a list of list. Is this a nested list? A list within a list? That's my guess, at least. And this is complaining because we don't return anything yet. I hope. I'm just gonna copy this here. And then read it. Split any white space. Each word becomes a list of symbols prefixed by space. Example, hi cat. So the space is only attached to the beginning of each word. The question is why there's a space here. I mean, there's no space like that. That might just be a typo though from the AI. I'm still wondering if I should go back and use these instead of an underscore. You know what? Let's do that. I don't like using characters that I can't actually type. But I might be saving myself a headache by doing it like this. Sentence is convention. Close this one. Okay, so sequence. List string equals a. Is this a list? No, equals empty, I suppose. For we in text, W in text split. If not W, continue. 6 append base plus list. And then we return it. I'm gonna include these here. def get pair counts. That capitalization there was sneaky. I almost missed it. Almost. Count, counter, tuple. So we are using tuple now. But I should probably ask still. What is a tuple in Python?
Sure thing, Angrask. So a tuple in Python is basically an ordered, immutable collection of items. Think of it kind of like a list, but once you create it, you can't change it. You usually write it with parentheses, and it's handy for grouping related data together.
So it's a sort of constant list.
Yeah, exactly. You got it. It's like a list that you can't modify after you create it. So it kind of behaves like a constant collection of items.
Can you modify like the values of the items, or is it just like the structure that you can't modify?
Right, so with a tuple, it's the entire structure that's immutable. That means you can't change, add, or remove items once it's created. Each value inside is fixed. So if you need something that you can change, a list is made flexible, but a tuple stays constant once you've set it.
Okay. So we loop through the sequence, the list of lists, and then we loop through each. No, we don't. We actually just check how many items the, or should I say how many lists the list has. And we use -1 for some reason. And I'm not entirely sure what this section does, but we'll get back to that. So we have a parameter called pair, which is a tuple, tuple, which is a constant. And then we have the sequence, which again is a list of lists. And we want to return a list of lists. And we have an issue of sorts. I think, but I can't spot it. Oh, one too many. No. There we go. And A, B, pair. Merge equals A plus B. New sequence, which is a list of lists. And we set that to empty. I think if we have a list of lists and then we say equals brackets and we put nothing in the brackets, do we just like initialize the list of lists, or what do we do?
Yeah, that's exactly what you're doing. When you say something like E equals open brackets, you're just creating an empty list. And if you plan to use that as a list of lists, it's basically just an empty container at that point. Later on, you can add other lists inside it, and it becomes a list of lists. So yeah, it's just the initialization step.
And do you have to initialize them, or is that just good practice?
It's mostly good practice. Technically, you don't have to pre-initialize an empty list if you don't need it right away, but doing so can make your code a bit clearer. It's like you're saying, hey, this is going to be a list of lists, and I'm setting up now so I can add things to it later. It just keeps things neat and understandable.
Great. It's always good to confirm your knowledge before running with it. And now we have a for or a loop for the sequence. I equals 0 out list, and we initialize this list, and then we check the length of the sequence, or as long as the sequence is longer than 0. And if the sequence is longer than 0, or the sequence -1 is longer than 0, and the first item, or the first list equals A, and the first list I plus 1, so the second list equals B. Merged. There we go. And then we iterate I plus 2. Else we only append that specific list, and we iterate by 1. I almost understand what we're doing here. Almost. I mean, I don't understand why we're doing this. Merge pair in sequence. So we're setting the A and B variable to be a tuple or a constant list of 2 values. And the merge is a string variable that is A plus B. Token after text merge. Concatenate strings. Do you say concatenate strings? Or how do you say concatenate?
Yeah, you're spot on. We usually say concatenate when we're talking about joining strings together. So it's kind of a fancy word, but basically it just means sticking one string onto the end of another.
Concatenate.
Yep, that's the way to say it. Just like that, concatenate. Basically, you're just combining strings together end to end, so you've nailed the pronunciation.
Concatenate, okay. Okay, another function, train BPE. We have text, string, vocab, size, an integer, and do normalize as a boolean that defaults to false, and do lower as a boolean that defaults to false. And we want to return a dictionary. I might actually be stupid, I don't know what BPE stands for. I just realized. That's a glaring issue. What does this stand for? The B might be for byte or something similar, but maybe not. Bytes per entry tokenizer. No, I have no idea. Byte pair encoding. So byte was correct at least. It's a simple sub-word tokenization method adapted from the 1994 compression trick, where you start a sequence of symbols, usually characters or raw bytes, in byte level BPE. Count all adjacent symbol pairs in your training text. Merge the most frequent pair into new symbols. Repeat step 2 to 3 until you hit a target vocab size, or no pairs are frequent. At encode time, you apply those learned merges in order to split any text into the same subwords. It balances vocabulary size, small, with coverage. Can represent any word as few subwords / characters, so rare words don't become unk. Okay, unknown I suppose, but still Anki is kind of funny. Notes that matter to you. Byte versus char. Many NLP systems actually start from bytes to be robust to all Unicode. Ours so far start from characters with visible space markers. Sentence piece style. The pair is just an adjacent symbol in the current representation. Popular alternatives word piece, BERT, or unigram LM, sentence piece. Same goal, different training objectives. 10 examples, conceptual. Text cafe symbols. Yeah. Frequent pairs might be space and C, C and A and F. After mergers, you might get tokens like K, FA, KEF, and A, etc. New words are encoded by greedily applying those mergers. Anything unseen falls back to smaller pieces, down to single character / bytes. I'm still not entirely sure as to why you need to do this. So, why do you need to do this? What's the point? I might just be missing the obvious right now, but I'm honestly a bit confused. My guess is that it's simply to make it more efficient. Like with the SSC compression trick. Okay, great question. Short version, BP and tokenization in general is how we turn raw text into manageable stream of integers that the model can learn from, without exploding memory / compute or running into unknown word failures. Why not use words as or characters, word level, short sequences, huge vocabulary, okay, millions of rare forms, misspellings, names, massive embedding softmax, character level, tiny vocabulary, very long sequences, needs long-range modeling to learn even simple morphemes. Simple morphemes. I don't know, I'm just thinking morphine when it says morphemes, but I don't English. BP, best of both. Open vocabulary, almost no unknowns, rare / novel words back off to smaller pieces. Compact vocabulary, manageable embeddings, and softmax. That's the second time softmax is mentioned. Shorter sequence for characters, big wins for attention, quadratic in sequence length. Language agnostic, handles names, emojis, code, multilingual text. Intuition. Text has a lot of repeated fragments. The Intion and _cafe. BP just merges frequent neighbors so common fragments become single tokens. Rare stuff stays decomposed. This matches data statistics so the model learns useful subword units without memorizing every full word. Concrete payoffs in your tiny LLM, faster plus cheaper training. So I was kinda right about that. Shorter sequences equals or is becomes fewer attention flops. Smaller model footprints, smaller vocab matrix, fewer failures, robust to typo / variants. Reversible pre-processing. With our space marker and normalization, decode is clean. Trade-off / gotchas. Segmentation can look odd. New York versus New York, depending on merges. Merges are frozen after training. New domains sometimes need retraining or larger vocab. If you truly need bulletproof coverage, switch to byte level BPE exercise 9, so every unicorn character is always representable. So that's the next exercise. Okay. TLDR, we use BPE to hit sweet spot, hit the sweet spot, small vocab, reasonable sequence length, and open vocab coverage, which makes training your mini transformer feasible on a normal machine while still handling real world text. But BP stands for byte pairing coding. But that's not the same as byte level BP though, or byte... Wait, pair encoding. Okay, let's go back to what we were doing here. I was wondering why that didn't register as a function. And words, 2 symbols, sequence, and text. Is another misspelled function? Yes, there is. Is a single function spelled correctly? Yeah, this one, okay. And this one probably. And this one. Yes. Good. And next step. If not pair counts. Then we break. Pair counts dot most common. So pair counts is a counter of tuple strings. I keep switching back and forth between having the comments and not having the comments. I should probably keep them all, at least when it's this complicated. Finalize vocabulary as ordered list. All symbols seen after the last merge pass. Collect from sequence to ensure only reachable symbols are included. Final vocab list. I will have to go through all of this with a fine comb before I understand it. It seems like there's like a lot of new stuff here. Stoi and ethos. Those are pretty interesting variable names. Using JSONify tuples. JSONify. That's a new one. But after all this, we return a model. So this is actually the full model then. Or this is the model, but after all of this, then we return the model. Is my assumption. But there's still a lot. Apply merges in the learned order, each pass replacing all occurrences for that pair. So this function applies the merges. And then we have a function called encode with model. Like that. No. Like that. Wrong again. Like that. That's the correct syntax. And lastly, vocab equals model. Vocab. And story. IDs. So we initialize that list. Wait, no, this is still the same function. This is a huge step up in difficulty from the last one. Absolutely massive. There's so many loops. So many unknown calculations and all that stuff. Fallback, break unknown token into characters should be rare if trained well. I suppose we'll have to see. Last resort, add a naive unknown mapping by extending vocab at runtime. Kept simple for this exercise. Value error. With an F string. My F strings are a bit more at my current level of expertise. That's how out of the water I'm feeling right now. Or in the water, I should say. Return a canonical string representation of an object. Oh, that was a function. That's better. Oh, return IDs. Empty quotation. Join talks. And then we have the command line interface. Okay. Ooh. But this is more familiar with the argument parsing and stuff like that. And then we have the main function that's actually running all the functions we just defined. And we create a argument parser. Argument parser. There we go. With a program title, or should I say name of tinybp.py, and a description of minimal pp tokenizer. Train, encode, and decode. The script. There we go. Our just complaint preset doesn't return anything yet. And a subprocess and subparsers. No, that's not the same. Subparser. I'm either forgetting it from before, or this is a new one. Destination, perhaps. CMD required true. PT equals sub add parser. Train. Train a BP model from text. And what was the BP? BP stood for bytes per encryption or encoding or something of that like. Encoding. Byte per encoding. Oh, a chest. And a duplicate. Okay. PT add argument. Input. Text file to train on. PT.add argument. Vocab size. Set that to an integer. Default to 200, and the help is target vocab size approximate. PT add argument. Normalize. Action store true, so it's a boolean. Help Unicode NFKC. PT add argument. Lower. Action equals store true. Same as before, so it's a boolean, and the help is caseful. Lower. And pt.add argument -o or --out. Default tiny bpe .model.json. Help equals output model path. Interesting, so we actually get a model file as a JSON file, but still, that's interesting. I want to take a look at that later when we've actually trained the model. P equals sub add parser encode. So PT for ptrain, that has to be. And then PE for encode. Yeah, and then PD for decode. Encode text with a trained model. We add argument model help path to model JSON. Group equals p.add mutually exclusive group required true. I have no idea what that does. And group dot add argument text help inline text to encode. Help. There we go. And lastly, GP add argument file. Help file to read and encode. PD equals sub add parser decode. Help decode IDs with a trained model. PD.add argument model help path to model JSON. PD add argument IDs required true help comma separated integers. I don't know what that required true means. Does that mean you actually have to use this parameter each time? Or something? Return p.parse args argv. I might be misunderstanding something, but it's a bit confusing because we return only the arg parser, but we have all these variables here, and we don't assign them anywhere to the arg parser, as far as I understand it. Or maybe no, I'm stupid, I think. So yeah, I'm stupid. We actually return everything since we have p, and then we sub equals p, and then pt equals sub. So we're actually getting all the way back here to the same origin point. Should this... So we are actually returning everything. That's good. I thought, like, what was the point of making all this code if we scrapped it at runtime? But lastly, we have the main function. argv equals none. And we return none. args equals parse args argv. And then if args.cmd equals train, then the data is the path args.input. Read text encoding UTF-8 model equals train BPE on the data vocab size plus args dot vocab size do norm equals args dot normalize and do lower equals args dot lower, I think. Yeah, and no. Then we have JSON can't store tuples. Convert merges to lists. Model to save equals asterisk model merges A and B for A and B in model merges path args out write text JSON dumps model to save ensure ASCII false indent to encoding UTF-8 and that's that. Oh yeah, we have the print. F saved model to args out the path, basically. Ooh, and then we have else if args does not say equal training. But encode then model equals JSON loads path args model read text encoding UTF-8 text equals args text if args dot text is not none else path args file dot read text encoding UTF-8 IDs equals encode with model text and then we print a JSON.dumps with IDs equals to IDs but we still have else if args.command equals decode. The last one model equals JSON.loads path args.model read text encoding UTF-8 IDs equals int x for x in args dot IDs dot split if x.strip text equals decode with model and IDs, print text. Holy, that was a bunch of code. A whole bunch of code. And I don't get most of it, which is kind of sad, kind of frustrating, kind of annoying. But I suppose learning by AI isn't perfect. I still need to ask questions. But I'm not going to do that today, I don't think. Because I can feel my throat is not well at the moment. I felt a little sick this morning, but I thought it had disappeared by evening, but apparently not. So I shouldn't strain my voice even more today. Perhaps tomorrow. Hopefully tomorrow I'll feel better, and then we can go through all of this and also do the testing or the trials, and of course the minimal testing with the PyTest. But the most important step is to go through all of this and actually figure out what each line does. Because there's no point in me writing a bunch of code that I don't even understand. I want to be able to write this on my own with like minimal input. Not from memory directly, but you know, writing the code and like having the structure in my mind, and as I go along, then like asking pointed questions to Google or an AI in this day and age, and getting some clarifications, but otherwise like doing it all myself from the ground up. And I can't do that if I don't even understand what I'm writing. So that's the next step. But I don't think my throat can take much more of this today. Kind of sad, but that's life for you. Anyway, thank you so much for watching, and please comment and like and subscribe. I'll see you in the next one. Have a great day, or evening, or morning, or whatever. Thank you.